Dear students, welcome back to this video series where we'll be looking at the application questions for Emath paper 2. So today the question that we have over here is actually from our 2018 O-level paper. Right, so let's look at the question together. Basically, this person wants, she runs a business selling sweets and she wants to design a container to hold the sweets. Okay, and how she does that is to use rectangular pieces of cardboard with the given dimensions 30 by 20, so the length 30 and the breadth 20. So she's going to use this cardboard to make the box. Additional information is given where 1 meter square of the cardboard weighs 210 grams. Okay, so 1 meter square represents 210 grams. Okay, next what she do is to simply take out scissors, right, and to cut a square from each corner of this rectangular cardboard. Okay, so if she change the size of the square she cuts, she can actually change the volume of the box. So that means the larger the square that's being cut out, the smaller the shaded area, hence the smaller the total surface area, right, and therefore the smaller the volume of the box and mass of the box as well, right, because the mass is dependent on the total surface area. So for the first part, we want to find out the mass of the box when she cuts a square of side 5 cm from each corner. Okay, so when she does that, right, the original breadth is 20 cm. Okay, so cutting 2 squares of side 5 cm, this gives us 10 cm, right, for the length. And for this length over here, right, this gives us 20 cm. Okay, so that's the reason why we have the total surface area to be just simply the area of the net. So the area of this green shaded area, right? And if you were able to partition this very carefully like that, you'll be able to find that this area is made up of 2 identical rectangles and 1 large square. Okay, so 2 times of the area of this rectangle plus the area of the square, and that gives us 500 cm square. Okay, but we are not done. We are supposed to find the mass of the box. Okay, so finding the surface area is not enough, and what we like to do is convert the surface area in cm square to meter square, because then we can make use of this relationship, right? So if you have forgotten, this is how we do it, right? 1 cm represents 1 cm represents 1 over 100 meters, right? Of course, 1 cm square represents 1 over 100 square meter square. Okay, and we multiply 500 on both sides. Okay, we will be able to obtain 0.05 meters, and the mass of the box will simply be 0.05 multiplied by 210, and that gives us 10.5 grams, which is simply the mass of the box when squares of side 5 cm is being cut out from this rectangular piece of cardboard, right, of dimensions 30 by 20. Okay, so we are done with the first part, which is relatively simple. Let's look at the second part. Part B, she cuts a square of side x cm from each corner. So now we would like to explain why the volume of the box is given by this expression over here. Okay, so as you can see, if the sides of the square that's being cut out is x cm, we would get a resultant length of 30 minus 2x by this length over here, which is given by 20 minus 2x. Am I right? So the total volume of the box is simply the base area, right, of the box multiplied by the height. And the base area is simply given by this rectangle in the center. Okay, and that would simply be base area multiplied by height. Okay, base area is 20 minus 2x by 30 minus 2x. Okay, finally multiplying the height, that gives us our desired answer. Okay, for B part 1. Okay, for B part 2, what do we need to do? we need to explain why the value of x, which is the length of the square that is being cut out, okay, must lie within this range, right, between 0 and 10. Why? Okay, this is an easy question. You can actually consider this question from the view that we require the volume of the box to be positive, right? Because if volume is positive, we would have this expression, okay, v of x, which is simply the function v with which is simply the function of x, right, given by this expression greater than 0. Okay, so how do we do that? To do that, first we find the roots of this equation. So that means when v of x is equals to 0, we obtain x equals 0, x equals to 10, and x equals to 15 respectively, which can actually be obtained from these two factors respectively. Okay, so putting these numbers on the number line, right, 0, 10, and 15, what we are supposed to do now is to find which regions or which interval, okay, is positive, okay, because this is what we want. So suppose that we consider the number 15 first. Let's consider an integer that's larger than 15. That means within this interval, right? There's no upper bound, so we can consider x to be, say, 100. Okay, that means when x equals to 100, what happens to this expression, okay, of vx, which is v in terms of x? Okay, what happens? We see that this term is negative, because 3 minus 2 times 100, right? Negative, negative, right? Positive. And the product of two negative numbers and positive number would give us a positive number. So any number that is in this interval, right, that means x more than 15, when subbed into the expression vx, would give us a positive number. If you repeat this argument, okay, you get negative, positive, negative. So now what we want to do is consider, right, these two range, okay, where x is between 0 and 10, or x is more than 15, which we reject, okay, and this is simply our answer. Okay, so any x values that's between 0 and 10 would give us a positive volume, okay, because v of x expression will be bigger than 0 for all x that is between 0 and 10. Okay, so this is the answer for B part 2. So now let's look at the part C. Part C, one wants to make a box, right, with a volume of at least 900 cm square, and she also wants to minimize, right, the mass of the box, because she wants the mass of the box to be as small as possible, right. In so doing, right, we would require a smaller surface area, right, and our job is to simply find out what value of x gives us this smaller surface area, which in turn will minimize the mass of the box. So in order to determine which values of x do we need, we simply need to consider, right, this information in the first line. We need the box with a volume of at least 900 cm square. So one easy way, okay, to do that is to actually consider a graph of v, right, against x. Now, with that, we need to find what values of x to consider and its respective values for v. Okay, so recall in part 2, B part 2, we have already identified this range. Okay, so we need x values to be integers between 0 and 10, so it means that x should be from 1 to 9. So I would simply plot x values from 1 to 9 and consider its respective v values from 1 to 9. Okay, so when I have that, I am able to plot out 9 points. Okay, 9 points, and I would simply join these points, right, using a French curve or a curve ruler, right, and you get this very nice curve, which is part of a cubic curve, given judging by this equation. Okay, so once we are done drawing this curve, we want to consider volume that is at least 900. So in so doing, what are we doing is simply drawing a horizontal line that intersects 900 across the graph, and we would simply trace what x values when these two graphs intersect. So we realize that x equals to 2.35 and x equals to 5.8. Okay, when the box has a volume of at least 900 cm square, sorry, 900 cm cube. So now writing this down, we have these values, and now we need to consider the formula for the surface area. So recall that we have this box. Okay, its length is 30 minus 2x, its breadth is 20 minus x, sorry, minus 2x, and its height is x. So now what we need to do is, okay, to find the total surface area of this open box, okay, in terms of x. So you see that we can do this in a very systematic way. Okay, we'll first find the area of this face. So this is simply, right, 20 minus 2x by x, right? So we have 2 of that. Okay, this is our answer. And the next phase that we would consider is this phase, 30 minus 2x by x. Okay, so 2 times of this quantity, and finally, let's not forget the base area at the bottom. So this is 20 minus 2x by 30 minus 2x. So this should be our answer. Right, so if you were to simplify this expression, we would get minus 4x squared plus 600. Right, they are intermediate steps. Okay, expansion and simplification. I want you to do it by yourself carefully. Okay, so the last 2 steps that we need to do is to identify what values of x minimizes the surface area, which in turn minimizes the mass of the box. So we have to actually compute S of 2.35 and S of 5.8. So you realize that when you do that, S of 5.8 gives you minus 4 times of 5.8 square plus 600, and that is 465.44 cm square, which in turn give you 0.046544 meters square. So this is the surface area of the box when x assumes the value of 5.8. Right, so if you were to do it diligently for x equals to 2.35, you realize that the answer is larger than this answer over here, and that's not what we want, because we want to have a smallest surface area which gives us the smallest mass of the box. So the minimum mass of the box, right, is 0.046544 multiplied by 210. Right, press this out on your own and you should get this answer. Right, correct it to 3SF and you are done. Okay, so that's the end of the question.